let us start today that auto transformer, which is the last part of transformer. Okay, now give heading that auto transformer. So first of all, we have to know what is auto transformer, Okay, let me tell you the briefly. See, what we have read in the case of transformer is that transformer is an electromagnetic device, okay, which is of two windings and they are isolated electrically, okay, but they are connected magnetically and we have a common magnetic path for the two coils. Yes or no? The same thing here in the auto transformer. In case of transformer we have two windings. In case of auto transformer we have only one winding, okay. So the one winding we have to get fractionized so that one portion will act as a primary and another portion will act as a secondary, okay. So here also we have, in case of auto transformer, the same transformation ratio, and we can also have that some things are primary and some things are secondary. So how to make fraction between primary and secondary, that also depending upon the transformation ratio, okay. Now comes to this auto transformer. In case of auto transformer we have only one winding. As we have studied about transformer classification according to the number of windings, okay, the transformer which is having only one winding, that is called as what? Auto transformer or variac. Yes or no? Variac. Similarly, the transformer which is having two windings, that is called as two winding transformer. And the transformer where we have three windings, that is, and the third winding is called as tertiary winding. Okay, so in case of auto transformer also we have two types of classification. One is step up, another one is step down. Okay, now let us first study the step down transformer. Okay, now this is called as step down auto transformer. Okay, so how can we distinguish between the step up and step down transformer? You can see here, so this is a core and this one is winding, okay, this one is core and this one is winding, whereas this is primary supply. So what current flows over here? That is I1, okay, and the current over here is equals to I2, okay. So only one winding where this much is the total number of windings are there, okay. So what we can do is that this, as this is N2 and this one is N1, so what is this portion of winding? N1 minus N2. Clear? So this is called as now step down transformer. What we are doing is that the number of turns in the primary is the same and the number of turns in the secondary is the maybe half or maybe some portion of the primary. Okay. So what this is called as now step down. So in case of step up, step down transformer, what we have is that V2 is less than V1. Okay, this is the case of step down transformer, as all of you know in the case of two winding transformer. So the same case will be reflected in the case of auto transformer. So auto transformer is a single transformer or nothing but a transformer where we have only one winding. It is in the case of two winding transformer where we have two windings are there. So the principle of operation and everything is same, okay. And sometimes some other books it has been mentioned that auto transformer will be acting as a resistance potential divider. Okay, resistance potential divider means what? Here we can divide the potential with respect to elements who are connected in series. Okay, but here what we have is that in case of auto transformer we can vary the voltage, we can up the voltage and we can down the voltage in the secondary side. Okay, in case of step up transformer what we have is that primary is the less number of turns and secondary is more number of turns, the same section. Okay, now when we have more amount of voltage in the case of secondary, that is called as step up. When we have less amount of voltage than primary, that is called as step down auto transformer. Okay, the only one reason is that we are having only one winding. Okay, now come to this point, why auto transformer is more efficient than the transformer. Okay, the first thing is that saving of copper. I think all of you know, in case of when we have two windings, we are having more number of coppers for primary and for secondary also. Whereas in case of auto transformer, what we did is that we have made only one winding where some fraction is total is called as N1 in the case of step down and some fraction is called as N2. Okay, so saving of copper will be counted here. So if saving of copper is there, so which losses will be going to minimize? copper loss is going to minimize. So when copper loss is going to minimize, we are having only two losses. The main prime losses are what? Core loss and copper loss. So when copper loss is reduces, we have only core loss. So the efficiency rises from 99 to 100%. Okay, so whatever voltage you are applying in the primary, the same portion you will get in the secondary, or you may get more in case of step up, or you may get exact less in case of step down. Okay, so it is nothing but called as resistance potential divider. Whereas in case of resistance potential divider, what we can do is that we can simply change the voltage. We cannot play with the current value. But in case of transformer, what we can do is that if voltage is less, then obviously current will be more. If voltage is more, then current will be less. In case of secondary and primary both. Okay, and the principle of operation of transformer and the principle of operation of this auto transformer both are same. Both are acting on the Faraday's laws of electromagnetic induction, that is E equals to n d phi by dt. The only one reason is that it will be useful where we require the variation of voltage. Okay, variation ranges of voltage. That means suppose your input is equals to 230 volt. You require starting from 0 to 230. So that means with a 10 interval voltage of you will want there. So what you that you have to do that this auto transformer you have to connect through the supply in parallel. Okay, first you will get 0, then 10, then 20, then 30, then 40, like this way up to 260 or 270, whatever the ranges are there, you will get that. Okay, so in case of auto transformer, how we are going to reduce the copper loss, that we have to count on here. Okay, so first and foremost thing is that all of you can see from the diagram itself, when we have less number of copper than a simple transformer. Okay, so obviously losses are going to minimized. So what amount of losses is going to minimize, that we have to find out. Okay, now before that, as all of you know, R equals to rho L by A. Yes or no? This concept has to be studied first. R equals to rho L by A. So what do you mean by R equals to rho L by A? So where R stands for resistance in ohm. Okay, where rho stands for resistivity and L stands for length of wire and A stands for cross sectional area of wire. Okay, so when R is increasing, okay, when resistance you are increasing, current area has to decrease. So the conductor which is having less area will have the more amount of resistance. So less area stands for more amount of resistance. If more amount of resistance is there, then current will be less. Okay, so area is directly proportional to current. Is that clear? When resistance we are increasing or when area you are increasing, the resistance has to decrease. So resistance decreases means current increases. So the area and current are both are directly proportional. So weight of the copper is also depending upon length of wire and cross sectional area of the wire. Okay, so the production of MMF we have to count out here. What amount of MMF we are counting here, that is N1, N2, I1 and I2. Okay, so how the saving of copper is going to occur here in the case of auto transformer, that we have to find out here. First thing is that all of you have understood here how the current is directly proportional to area. Okay, from this formula. Okay, similarly if length is increasing of the conductor, then which is going to increase? If R is increasing, then length also increases. So if length increases, then current decreases. Are you getting or not? If current resistance increases, if length increases, resistance is increasing. If resistance is increasing, then current is going to decrease. So you have to make a conductor or you have to make a copper inside the transformer where we have to balance the current from output to input or input to output. Okay. So in case of an auto transformer, when secondary side is there, step down, then less number of turns are there. Okay. As all of you know, what does this stands for? EMF per turn or voltage per turn. Okay, similarly voltage per turn. So voltage per turn in primary, voltage per turn in secondary. Okay, so from this we can get the transformation ratio. How much? Yes or no? This is transformation ratio. Okay, so this equation will be really used for the finding out how much amount of copper we have shaved there. That means EMF per ton you have to find out there. Now see, EMF per ton means what? What is the amount of voltage is going to produce under what amount of turn. So this is what the case for two winding transformer. Now in case of auto transformer it is quite reversed. How? Now see, what is the EMF per turn in case of primary? V1 by N1. But in case of secondary, what is the EMF per turn? If this is the current flowing over here, I1, and I2 is going to flowing from this side, I2 minus I1. So what is the value of voltage there? Secondary voltage is equals to how much? V2 by N2. Are you getting or not? If primary EMF is V1 by N1, secondary is equals to V2 by N2, then what is this portion remained? How much this voltage it will provide there? So what amount of voltage it is going to provide, that we have to count here. Okay, so because primary, when you are applying the supply to the primary side, what we have is that we are having the supply like this way. Okay, now it is coming here. So this is tapping. This process is called as tapping. So we are having several number of tappings in the primary winding. Okay, for example, our load is connected between this point to this point. Okay, this point to this point. So now how going to voltage is going to reduce, that we have to find out here. So for example, here equals to we have N1 voltage. Okay, now here it is N2 number of turns. So what is the remaining turns here? N1 minus N2. So what is the voltage in the case of primary? V1. What is the voltage in secondary? V2. So what is the current over here? Same I1. Because I1 is flowing, I2 will flow when the load is connected between this point and this point. Yes or no? So we have decreased the secondary side. The same winding is there, we have decreased the secondary side. So the operation of principle of operation in case of transformer and here both are same. The thing is that we have different windings, positive point. If this is positive and this is negative, if you make here positive and here negative, then the voltage is going to supply from here to here. These all voltage will not be counted. Okay, for example, this is total is equals to 230 volt and this much voltage is equals to now here suppose 10 volt. So the output will be connected to 10 volt. If this is now exactly at the half, this is 115 volt, so this is 115 volt. Okay, so from here to here this is 115 volt. Now how the current is going to flow in the secondary side, that we have to find out here. So for example, this is I1. Okay, so try to see according to the KVL, find out the loss, that is direction of current. This is I1. Okay, I1 is flowing in this way. Now I2, how it will flow? I2 will from here to here. Okay, again I1, this is. Are you understanding? I1 has two flow. This is positive, this one is positive, this one is negative, for example, or if you can say phase and neutral. Okay, positive, like this way the current is going to flow. Okay, current is going to flow here, I2 current. Similarly now here again I1 current is again reducing. Okay, so in case of auto transformer, what we have is that only one winding is there and we are supplying the total primary voltage to the primary winding. Okay, this is in case of step down transformer, and secondary side we are getting the some voltage or the portion of voltage or fraction of voltage of primary, you can say. I1 minus I2 will go down, but what I have written here, I2 minus I1. So what is the voltage here? If I1 is here, I2 will flow like this way. So this remaining current is equals to what? I2 minus I1, I1 minus I2. So I1 minus I2 means that will be flow in this way. Okay, there are some current which is flowing I2 minus I1. Okay, that is called as, for example, this is A, this is B and this is C. Okay, if current I1 is there, this is I2. So what is the current flow in this direction? I1 minus I2. Yes or no? So which one is positive? This one is positive, this one is negative. Okay, now it is current is fully divided. Okay, I2 minus I1, how it is flowing, that we have to find out here. Due to this only we are having the minimization of copper loss. Okay, due to this only we are having minimization of copper loss, that is how. Okay, so now in case of step up transformer, what we have, I told you, the primary voltage is less and secondary voltage is more. So Okay, now this is called as step up auto transformer. Okay, step up auto transformer means what? We are having, this is primary is less number of turns, whereas secondary is more number of turns. Okay, as the turns directly proportional to voltage. Okay, so if primary is having less number of turns, so this is the less voltage. We can get maximized on the secondary voltage. Okay, so now this is V2, so where we are getting the most amount of voltage than the primary side. Okay, so in case of step up auto transformer, here also the principle of operation is same. Okay, so that means what? Primary current is more and secondary current is less. Are you getting or not? Here primary current is more and secondary current is less. If you are having more amount of voltage, obviously current is less. See, in case of transformer, the first and foremost principle is that input VA is equals to output VA. Yes or no? Input VA is equals to output VA. There, for example, VA. Or else what we can define that? Cos theta 1 is equals to, or cos phi 1 is equals to cos phi 2. Okay, input power is equals to output power. If primary voltage is less, then primary current will be more. In case of two winding transformer, if primary voltage is less, then current is more. If secondary voltage is more, then current is less. Okay, now here what we are doing is that primary current is more, okay, and secondary current is obviously less. Here also the same transformation ratio formula, V2 by V1 is equals to E2 by E1 is equals to N2 by N1 is equals to I1 by I2 is equals to K, whereas K less than unity. If K is going to unity, then how much amount of copper we are going to save, that we have to find out. How we are getting more? So here also we have to make same. That is a good question. See, output volt ampere and input volt ampere we have to make as a equal. Okay, otherwise it will not be called as a transformer action which is going inside there. So how output volt ampere will be equal to input volt ampere, so that the current will also be changed. Okay, so if primary current is more, then secondary current has to be less. If secondary current is more, then primary current has to be less. So that balance we have to make here by that formula, that transformation ratio. Okay, so remember all of you, first of all, this transformation ratio formula is that V2 by V1 is equals to E2 by E1 is equals to I1 by I2 is equals to K. Okay, so I1 equals to what? K into I2. So if K is less, then what will happen? I1 equals to what? I2 into K. If K is less, then what is going to happen? And if I1 equals to what is the formula there? Okay, see there. So I1 equals to what? Yes or no? I1 equals to K into I2. If K value is less, then what is going to happen there? I1 will be, if K is less, then I1 will be more or less? See, the current I equals to, if K equals supposed to equals to 1, for example, K equals to 1, so I1 equals to I2. And if K equals to 1, then I1 equals to I2 or not? Okay. If K equals to 0.5, then what will happen? So you take some value of I1, no? I1 equals to suppose 4 ampere. So K equals to now 0.5. Now it is equals to I2. So what is the value of I2 there? What is the value of I2? Less or more? More. Are you getting or not? So 0.5 is equals to 1 by 2. So if you multiply there 4 into 2, so 8. Now getting? If so, K less than unity should be there. Here also we have, that is the principle. That's why I am saying that as usual, if you see by the KVL, the direction of current I1 equals to like this way. Okay. Now I1 flows in this way. Okay. So when we have this current, so this current is now called as I2. Okay. So I2, if I2 is remaining here, then what is the remaining current flows over here? I1 minus I2. Okay. So I2 minus I1 current is there, which is producing the MMF, which is opposing nature to the I2. Are you getting or not? I1 minus I2 is the amount of voltage flowing in the transformer, flowing in the secondary winding. Here I1 minus I2 is flowing. Okay, but what we have to is that there is some MMF which is opposing to the applied primary voltage. Okay, so whatever MMF is opposing to the applied voltage, that is due to I2 minus I1. That is due to I2 minus I1. So MMF is there for the primary and secondary also. If voltage is produced in the case of transformer, how we are getting E1? When we are applying primary voltage V1, E1 is the opposing to that by Lenz's law. Yes or no? Similarly, in the case of secondary winding, when current is flowing over here, that is what, how much amount of current will flow? I1 minus I2? Yes or no? So when I1 minus I2 is flowing there, so there is also some amount of MMF which is producing and opposing back to the applied MMF. Okay, so what amount of applied MMF is producing back, that is will be counted from I2 minus I1. Okay. So same in the case of step-up transformer. In the case of step-up transformer, what we have? When we have, this is primary winding, this is number of turns in primary, and this is number of turns in secondary. Okay, so here voltage is more than the primary or less than the primary? More than primary. If voltage is more than primary, then what should be the value of K? What should be the value of K? Greater than unity. So, but it should not be greater than unity. K value should be between 0 to 1. So now you have to decide what amount of voltage you have to apply in the primary, so that that portion of voltage you will get in the secondary. Okay, so step-up auto transformer is very rare. Very rare in the case, because here also the same formula. Okay, now what is the value of V2? V2 is equals to K into V1. Yes or no? V2 is equals to K into V1. If K equals to 1, then what is the value? V2 equals to V1. Okay, or N2 equals to, you can also find out, N2 equals to K into N1. Okay, number of turns in secondary side should be is equals to K into N1. So now here number of turns is more in the case of secondary winding. Yes or no? Number of turns in the secondary winding is more than the primary winding. So primary winding takes only, for example, this diagram shows that, or this diagram resembles that, only N1 is having half number of turns of this N2. Yes or no? So this is half and this is full. So N2 equals to K into N1. So now K value you have to decide in such a manner that N2 and N1 should balance there. That means whatever voltage you are applying in the primary side, you should get more than that voltage in the secondary side. Are you understanding or not? You should get more voltage in the secondary side. So this voltage is less and this voltage is more. Okay, how we are getting more voltage, that we have to find out here.
So K should always range up to unity.
K value should be lies between 0 to U1.
V2 will be higher.
Obviously V2 will be more than
Then sir, it will be.
if V2 will be more than V1, now see, what we are making is that finally the power should be same. Power should be same, that you have to concentrate. If V2 is more than V1, then what we can write down for I2 and I1?
I2 will be
Less than I1. So we can make V2 I2 is equals to V1 I1. Okay, if current is going to reduce, then only output power and input power both will be same. Okay, so this one you have to concentrate that how much voltage you are going to produce or how much voltage at the output side, that will be decided. That is in the case of step down transformer. Okay, so step down transformer and step up auto transformer, both are the principle of operation is same. That is Faraday's laws of electromagnetic induction. Okay.